What's up, everybody? Follow the link in the description to download all the code you'll need by clicking code, download zip, or any other way that you already know how to get code from Git. How's it going? Thank you for joining me on this video series. We're going to make Snake with Python. It's almost like a rite of passage. I'm sure you know what the game is, so let's just jump right into it. We're going to be using Pygame. So I'm writing in a script, Python, using Visual Studio. If you don't know how I got to this point, you don't have Python at all, I have a video on how to install it. So before you start here, I would recommend getting Python on your machine. If you are ready and know where I'm at, we're going to start this by making a main function. Type out like you see there, and go ahead and initialize our first Pygame instance with pygame.init. Go to terminal and new terminal, and we'll be at a place where we can try this out by typing snake, and this is actually in the source, but wherever your Python file is, you can just type that out, and you can see we got our first message from the Pygame community, which is pretty cool. So we know that that's working. If this isn't working for you, it could be because you haven't installed the Pygame package. To do that, you need a command prompt, and you'll use pip. So you can search cmd here and run as administrator. And type in pip install Pygame. You can see I already have it installed, so that's why it's working. Back to it. Now that we have our Pygame module, we need to start making a display where this game will run on. In Pygame, you do that by doing a display set mode, and essentially you just need to give it how big you want your screen to be. And that will look something like that you saw for half of a second. You only saw it for half a second because there's nothing telling it to stop. Not to stop. So let's make a while loop here. This is a loop that will run until something becomes false. But if you put while true, it will continue to run forever unless we interrupt it. So you can see that we have a window here. It's kind of running it forever. It's not really the best way to do this, but we'll get back to that later. I can click on the terminal and hit Control-C, and you can stop the execution. There's a couple of things we want to do then. We want to have a little snake running around. So you need to import an image that Pygame can use to represent the snake. So it's pygame.image.load, and then you just have to give it a location of where to look. You can see on the side here in source, I have this thing called block snake. So source, this dot means where I am right now, dot source, dot block snake, and it's a JPG. Now that we load it in and we've given it a name, we can put it onto the display by using the blit function, which essentially puts something on to the display. You give it first what to do, the block for our snake, and then where to put it. So maybe we could just do something simple like 100, 100. Here, file not found, and you can see that it said source clock. It's because it doesn't recognize that I meant source of block. So let's go ahead and run what we have so far and see if we get a little block, which we did not. And the reason for that is because we need to tell Pygame that we're basically done putting things onto the screen, update the screen with a pygame.display.flip. See if that works out any better. So there you go. We have our white snake block. That's wherever 100, 100 is. So we're on our way. What we really want this block to do is act like a snake. And as you move on the keyboard, it will move around. And what's going to save us a lot of time is creating a class that represents what a snake is. So in Python, you can make a class by typing class and give it a name, generally with an uppercase letter. And then the first function you need is init. Using Visual Studio helped me create this function. There's an object variable called self, which is basically telling me anything of the class snake that relates to self. If I have more functions, which we will have, functions meaning this keyword here, def, where you can call it, kind of like here, like a flip. We can create our own functions, which we'll get to in a second. First, we need to think about what things are going to be important for us to know about a snake in coding terms. We need to know where it is, and this is a 2D, so we give it a self.x and self.y, so we'll know where it is. The other thing that a snake does is it kind of is moving. So we can give it a direction that it's moving in. And we probably want the snake block to be something that we keep inside of the snake as well. But it wouldn't make as much sense to call it snake block. We can call it body maybe. And we'll load in the block there and get rid of snake block. So we have where our thing is, where the block of our snake is, which direction it's going to move in, and then what it actually is being loaded as, the actual image. This while loop is going to control everything that happens in this program. It's going to keep us going while our game is running. So we want to make some kind of a variable that tells this while loop while it's still running, which we set it equal to true at the beginning, keep on going. And as the game is going, the computer needs to be looking for, did they press the left key, the right key, the up key? Pygame does that by using a function called pygame.event.get. Essentially keeping track of what events happen. The types of events that we're interested in are the keyboard events. So we can actually just say if the event type, so if it's an event type of key down, there is a key down is not defined. That's because we need to import again from pygame.locals import, and we'll just import everything, which is a star. So that lets us use some handy preset variables like key down. So now that we know that it was a key pressed on the keyboard, we want to know what kind of key it was, if it was left or right or up or down. To get that, you do event.key and check it against key underscore right. Will be user clicked the right arrow. So we'll get back to what we want to do when that happens, but let's go ahead and create several different ifs for all the different types of key presses that we're interested in, right? And then key left and key up and key down. And go ahead and update those. This is a series of ifs. We want to be separated by using else if, which means if this is true, go ahead and run this code else. So if it's not true, we'll try this one. And if that one's not true, try this and then this. Without that else, it will try all of them all at once. It's not what we want. When you press the right key, it will change the direction of the snake when you're playing the game. So it'll start heading to the right. So we need a way to change the direction of our snake. And we've given him already in our initialization or making of the snake a direction. So let's go ahead and the correct process for this is to create a function that allows us to interact with the snake's direction. Every time you make a function in a class, you will start by giving it the self parameter. And in our case, we need to give it another parameter for the new direction, right? So anyone calling this function needs to tell me what key was pressed, what direction do you want to go? And all that we want to do is access the direction of the snake that we've established with the self and change it to whatever they passed in, right? Whatever new direction. So here I can now call snake dot change direction, and I want it to be right. You can see that it's not very happy with me because we haven't made a snake yet. In the main function, we are able to create classes, and I want to create one for my snake. This will make an object out of all this code that becomes something I can interact with, such as snake.changeDirection. To make a snake, after you've defined the class, you just simply write the name of the class and give it any parameters that it needs. In our case, we don't need any parameters. We're fine just building it off from scratch. And we said it'll always start right here at 100 and 100. It'll have all of these different attributes. Not sure why snake block is there. We don't want that. So now that I've created a snake, it knows what I'm telling to change direction. And then we want to rinse and repeat. If the direction changes for any of these, we want to do the appropriate action. Up and down. So I just noticed that we have an error here and it's yelling at me that key up is not defined, and that it's been sneakily importing different things for me. That's because this isn't K, it's just K. We don't want the full key. Let's go ahead and fix that up. Now it's not so mad. So now we can change the direction of the snake, but we have not yet told the snake how to move around. Remember, we had our blit function that will put a block at any pixel, right? So let's use this code again and create another function in our snake class that we will probably call move snake. So when we move a snake, again, let's give it our self. We shouldn't need anything other than the direction to go. So we have, instead of snake block, remember we changed it to self.body. So now the question is, we don't want to just always write it to 100, 100. We want to write it to snake.x. So we'll place our block to wherever this variable is that's going to keep track of where our snake is going. We have a direction, but the first thing that we need to do is kind of change where snake x and snake y is. Nothing is changing that. We need another function that says move. Let's call this one move snake, and then we will call the other one draw snake. So now we need to just mess with our x's and our y's, and we might want to copy this because it will correlate pretty similar. Instead of using k left and right, we want to make a decision based on the direction of our snake. So if self.direction, these are off, equals right, we need to put it in parentheses here. Then we need to move the snake, correct? Yes, it's probably easier to just get rid of that and start one by one. So the way we move our snake is we change our x's and our y's. If we're moving to the right, our x is going to increase. So you can do plus equals to add 10 to the original value, let's say. So this will move the x value of our snake over 10, as long as he's moving right. So before we draw the snake, we always want to move the snake. So we can use self.moveSnake. Right now, it'll only work if he's moving right. So let's go ahead and fix that. Make our else if again. And we have left, which would then subtract 10. And then we have, this is why I thought maybe we could cheat and use our other code, but now we're going up and down. We want to affect our y. So if he's moving up, we want to subtract 10 from the y, I think. We can test that out. And if it's going down, we'll add 10 to the y, move our block down. So let's see how this all works. The only problem is we have no function calling draw snake. So we have this event logic waiting for arrows to be pressed, but always in the meantime, we want our snake to be moving. So in the middle of the while loop, we will just always call snake.draw snake. Just always keep him moving. So let's go ahead and give this a try. There's a couple of things that we'll see right off the bat. You see that it zoomed off really fast. And also we're not replacing where the snake was before with darkness. So let's close this down. It would be nifty to have a way to close this down. There's another event type called quit. When I click on that X, so let's make that change our running variable to false. And when this changes to false, this next time it comes to the top of the loop, it will know I'm not running anymore, and that will let us actually quit. The other thing that we noticed was the snake was moving so fast. So we need to give it a little bit of a a time before it draws the next block. And we can use that by just giving a little delay with the time module. So we have not imported it. So let's import time so it knows what we're talking about. And then time.sleep will allow us to wait a little bit before the next block is drawn. So let's try this again. You can see that it's moving the 10 and I can move it around. I'm pressing on the keys, which is pretty cool. But we want to, and the X works now. We kind of want to delete and refresh the screen every time. Display has another function called fill that allows you to give an RGB value. In our case, we are just using a black background. You can go crazy with any background that you would like. So when we move the snake, this will fill everything to blackness. So whatever was there before will go to black, and then we'll blit a new one and then flip it or update it so we can see the changes. So let's go ahead and try that. You can see now that it's refreshing itself and we're moving around.